Um, Great to see so many people here. It's a fantastic turnout, so thank you all for coming along. Normally we don't run the events over the summer because of vacations time, and it's hard to fill a room, but this is a great turnout. And the reason I guess you're all here is because of the Internet of Things. It's a technology wave that is going to impact us all. We all want to either understand it, help create it, or benefit from it. And what's fascinating from my point of view as a guy who started in physics and has ended up in software is the Internet of Things brings together devices, sensors, processors, networks, software, and data. It glues the whole thing together. It is all of the parts. And from the IoT point of view, I feel like it represents or involves more of our membership almost than any other wave of technology I can think of. And it's going to be transforming. I would say, because I'm a software guy, the greatest of these is software. And that's why it's a particular pleasure that we have Hank Skorney with us this evening. So let me tell you a little bit about Hank. He's a wonderful man, and I worship the very ground he walks on, which is because he pays my wages. But setting that aside, there are other reasons why it's great to have him here. Hank's actually originally a biochemist, so he knows more about folding of proteins than is probably decent in a man of his age. But the process of figuring out how molecules fold led Hank into software, and from there he progressed a career with a number of companies, headline companies in software. He's worked for Adobe, he's worked for Microsoft, he's worked for Apple. He was at AOL, where he led the development of their messaging technology, so he knows a great deal about connecting people together. And from there he found his way to Intel. And at Intel he runs Intel's software and services business. Now, not many people, apart from perhaps Michael Caine, know that Intel is the 5th largest software company in the world. So we're all well used to thinking of them as a hardware company, but huge number of software developers at Intel. And in the past, most of that software development was to enable the sale of silicon, of processors, of devices. But that's changing. Hank is leading the organization in a pivot, if I may use that word, although it probably does get overused, to bring that machinery to bear on the creation of the Internet of Things. And without software, the Internet of Things is just a bunch of devices. It's the software that actually makes it truly compelling and interesting. And so I'm delighted to have Hank here with us this evening so he can tell us more about what he's trying to accomplish and his vision for the Internet of Things. Thank you.
Thank you, everyone. And so tonight what I'd like to do is take you on a little story for how my group within Intel, which is a very significant size group that's leading this revolution and change inside Intel regarding the Internet of Things. It's something we believe is really the next wave of computing. If you look across the lifespan of computing, from mainframes to PCs to mobile, we believe that the next major shift that will occur is really around the connectivity of humans and devices throughout the world with intelligence in orders of magnitude that have never been seen before. So, just some of the elements of the Internet of Things, they range from devices that you wear, that are inside of you, that you utilize in sport, in industrial applications, to manufacturing facilities, to your home heating, childcare, almost anything that you can imagine in the world today, we believe will be automated in the future with massive benefit to humans and society as a result in our environment. So you constantly hear people talk about the Internet of Things, and they'll say, wow, this is big. As we start to look at it, and I look at it, it's not big, it's massive. When I look back to my beginnings back in the world of the PC, when I saw the first signs of the PC where I went from modeling three-dimensional proteins on banks of mainframes in rooms 3 times this size and submitting jobs off to Cray computers to suddenly replacing them by a small box that ran off of wall power with no air conditioning specialty, that was a massive change in our lives. Then back in the early part of 2000, you start to see mobile come out, and you had a revolution of mobile phones. And then tablet computers came out. But now what you're starting to see is computing technology, intelligence being built in to everything on the globe. And you already see it in the fitness bands that you wear, in thermostats in your home, the industrial machinery that makes the products, goods, and services, and the healthcare that takes care of you today. So let me just give you some numbers. And these numbers come from a large variety of sources. Anywhere from companies like General Electric to Cisco to Bain Research to Accenture. They all line up to nearly the same set of numbers. If you look at it, the Internet of Things today already exists. There are nearly 15 billion devices already with intelligence built into them, connected or not connected out there today. So there is already basic intelligence. It already exists. And that's one of the things you want to look for in new markets. New markets typically aren't formed just by raw revolution or innovation. They're formed by evolution. So if you look at it, there's already 15 billion opportunities sitting out there for you today. And one of the main things that's occurring today is starting the connectivity of these devices and the upgrading of the intelligence that's being built into those devices. We're also seeing a massive acceleration of the amount of intelligence that's being built into every one of those devices, as well as the proliferation of those devices into nearly everything known. In a typical GE jet engine today, which GE is one of our main partners, we announced a partner around the industrial internet last fall with General Electric, Accenture, a number of telephone companies, Cisco, Accenture for systems integration. If you look at some of their solutions today, the typical jet engine that GE makes has around 125 sensors. The next generation that they'll ship this year has well over 10,000 sensors in it. That's engine of today with 125 sensors in it typically generates 1 billion copies of War and Peace on a 6-hour flight from New York to San Francisco already today in sheer volume of data. It does everything from real-time monitoring and real-time control of the systems to offloading data for advanced analytics of that information to add more intelligence, to maintain the engine, for fuel efficiency, for environmental efficiency, for design of new engine efficiency, and for safety, of course, for that flight. So you can see just single examples of how this explosion is going to occur. In fact, one might say that the number may be too small. but the economic realities driving it are just too massive. That same GE jet engine today, being deployed since 2012, because of those 125 sensors, can take the typical flight that is 2 hours or less, where 40% of all fuel is consumed on takeoff or landing, and through simple analytics on the wear of the turbine blades, the heat characteristics of the turbine blades, the revolutions of the turbine blades, knock off 5% of the fuel consumption and hence the emissions of that jet engine for that 2-hour flight alone. They also can monitor the wear of the turbine blades down to the micron level by using acoustic listening devices that actually listen to how the engine runs. When I met with the GE jet engine manufacturer, the lead engineer, he said the way he started off the conversation is, you know how when you're driving and you listen to your car engine and you say, I think something might be wrong. Exact same thing we're doing here, just with an acoustic listening device. That means things like volcanic ash, erosion on the blades can automatically be measured, and you can use the blade dynamics to automatically and instantaneously adjust fuel consumption and have a massive benefit. This is not even counting maintenance costs, because no longer are you simply doing maintenance costs at X hours of service. You're doing the maintenance when it's needing to be done, not just on some arbitrary schedule. All of this, by comparison, today there's roughly 10,000 mainframes in the world. There were roughly twice that at the peak. There are 1.2 billion PCs in the world today and 1.5 billion smartphones in the world today. These numbers are actually flattening out. PC industry is largely flat, a replacement industry today. The smartphone industry is more and more becoming a replacement industry. And in fact, just as a data point, in the Western world today, over 50% of all new mobile net adds, new accounts, are non-human devices. So all of the new subscribers that you are seeing each of the mobile operators boast of, they're not humans, they're things. So the connectivity that is going to start to take that 85%, link it together so that one can add intelligence, is already well in process. So you have a base of devices already out there, the trend of connectivity already starting to occur, and the proven economic benefit necessary. If you look at that trifecta, that's what it takes for a new industry to form and for opportunity to be made. And the reason why Intel's in this is that if you look at across the lifespan of the largest corporations in the world, we've been around for nearly 50 years now. Companies are made or broken, new companies are made or broken by looking for key trends that change the playing field. Right? You saw companies like Digital Equipment Corporation go straight down the tubes when they didn't make the transition out of mainframes. Wang Computer. Does anybody remember Wang computer systems for the older ones, the older people in the audience? The top word processing computing system in the world. Massively profitable. In fact, they were profitable right up to the day they padlocked the doors because they didn't make a transition. So at Intel, we are absolutely committed to making this transition. We see this as the single largest new opportunity to reinvent Intel ever. So what does this create in terms of the sheer magnitude of data and of transactions that this 50 billion devices coupled with the PCs and the mobile phones and all of the other connectivity that occurs out there? So if you start down at the bottom with services and software that start to form, and you start to build basic solutions out of them, what ends up happening is every time you connect a point of sale terminal, you're adding another server instance in the cloud. As you start to add medical devices, and these are all averages, of course, 100 to another server. And these numbers will only go up in that as you collect more and more data, you will generate more and more need for cloud to device interactivity. Another area, if you're looking for smelling for opportunity, right, is great, big data and analytics you're starting to see as one of the biggest opportunities here. Vending machines, video cameras per sensor, as you just tick up industrial controllers, it just is a spiraling effect. More devices begat more data, begat more servers, begat more cloud. And it just continues to go up and increase in orders of magnitude with each new device or new capability that enters the network. So if we look at then what are some of the key elements of this Internet of Things? If you look at a world where there's 50 billion devices, what you start to end up with is massive amounts of data. The prediction, 35 zettabytes, which is 35 trillion gigabytes of data that's collected from those devices and generating application programming interface, or API calls, where you pass instructions or data back and forth, that is equally in the trillions. And oftentimes that's not even including all of the overhead that's necessary to transport that information. People who create applications that can manage, make more efficient, and take advantage of all of these devices, the traffic that they generate, and the data that they create are going to be the winners, we believe, in this next generation of computing. So I'm going to talk a little bit more about APIs because I'm going to link that back to our acquisition of Apona. Apona is in the API business, and what they do is create services that make it easy to use APIs and easy to use APIs with the communication network. So I'm going to zero in on this a little bit, and it's important because the way software used to work, a long time ago, you took a piece of code, you ran it through a compiler, and you got software out the other end. And everything you needed for that software was self-contained in it. Then, as applications moved up to the cloud, and as more and more devices formed and more applications ran on those devices, you end up with software applications that dwarf the 50 billion devices by 2020. and you need some way to connect them all. So therefore, you need a common language for them all to speak. So that's one of the reasons why we came to Northern Ireland and invested in Apona, and now are building out a team to be specialists in this area here. And something you ought to take advantage of as a local resource in new opportunities that you may want to pursue. If you look at this, whoops. Mind if it's on? Built-in intelligence. So if you look at this, one of the things I wanted to call out is that the world of using APIs to communicate with devices in massive volumes already exists today. If you look at the volumes of APIs that are being created today and run today, it is already a massive amount of information is being exchanged between applications, devices, and services that are built. A great example of one is a company, Expedia, which I think probably a lot of you use. And actually, more importantly, a lot of you use Expedia a lot more than you think. So Expedia, which makes a travel website today, actually makes 90% of their revenue running other people's travel sites. So when you use Kayak, when you use Hotels.com, when you use, I'm trying to remember the Hotels.com aggregator here. There's a name, that one that goes through and searches everybody. Yep. No, there's another one. I can't remember the name of it, but they all use Expedia. Air France, KLM, Delta, they all use Expedia. Their entire business is run off of cloud software that uses application connections to connect them all and to connect to all those intelligent devices. They're already starting to do things now. One of their newest businesses is to take literally the Expedia travel management system and load it right in to take and link into the flight itself to do load factoring, load balancing, weight balancing, predictive analytics on when people show up to the airport, so that their service offerings just expand way beyond people simply purchasing tickets. So you'd be amazed at how much information is out there for them to collect to do these analytics today. So I'm going to come back up a level now and talk a little bit about the overall IoT marketplace. It's interesting, us being a silicon company, one of the things that we realized is we have to invest even more in the software. Hence why we're one of the top software companies in the world. We make well over $2 billion in software already today at Intel. We actually, our IoT division makes well over another $2.5 billion already today as well. Most of the chips in your car, most of the chips in the plane, most of the chips in the street lamps are already Intel chips today. So this is all about us accelerating that further. And what you'll see is us accelerating it in a big way through software and services. A lot of people are attracted to the hardware, to the cool devices, but where you really are making the money is through the software and services. And I might point out that the typical margins in the silicon business, we enjoy some of the best in the industry, up in the 25% range. But typical margins in that business are down, at best case, in the low 10 to 15 range. Software, net margins of 40%, and services can be north of 50% in terms of actual profit per dollar made. And if you look at some of the areas where there are the specific opportunities by 2018, you really start to look at things like horizontal platforms, applications and software that build out value-added service, data infrastructure in order to contain all of that data and connect all of those devices, system integration, and then finally the actual network services that communicate all the information. So as you're looking at what opportunities do I want to invest in, what opportunities do I want to form new companies in, it's really around software and services is where the opportunities are. And the other good thing is it's the quickest to market. So what do we see as some of the key segments that are where we are focusing today and where we think there's opportunity to focus? So first of all, consumer. A lot of people are attracted to the sex appeal of consumer. Recent data shows that in the Internet of Things world, that the venture capitalists today invest over 70%. I think it's roughly 72% of all dollars deployed today are in consumer IoT devices. Yet, if you look at the revenue forecast through 2020, only 20% of the revenue looks to be made through that area. So one of the things that as you're starting to look at where is there opportunity, a lot of the opportunity comes back to the enterprise, fixing real problems that can have massive impact on humanity. And by enterprise, I mean B2B, which may ultimately end up in a consumer product, obviously. So in the consumer side, wearables is huge. Wearable fitness, entertainment, continues to be in mobile applications. Smart home, you see a lot of advancement in smart home, things like Nest and the purchase by Google. And then, of course, smart car technologies. In enterprise, where we see huge opportunities, in fact, the first two segments that we're really focusing in on today is energy and transportation. I just gave you the example around the GE jet engine, but there are countless examples where you can do things like make micro adjustments to the power grid in order to save vast sums of energy. 40% of all the electricity that is generated on any given day is pumped back into the ground. The reason being is that when you turn on the light switch, you expect it to go on. And so the capacity has to be in the system so that when you randomly decide to flip on that light switch, it needs to work. Massive peaks of consumption occur every day between the hours of 8 to 10 a.m. because a bunch of people walk into their office, turn on a switch on the computer, turn on the lights, and the air conditioning has to kick in to cool or heat the building. And what that causes is a very uneven distribution of the ability to generate power. And things like wind farms and solar farms do absolutely nothing for that, because it's not like you can mysteriously tell the sun to shine, especially in Northern Ireland, or I'm from Seattle, so it's the same thing. You can't just say, turn on the sun today. Between 8 and 10. So huge opportunities there. Health is an obvious one. Already working on technologies to do things like computer-assisted independent living where we can use radio fields to monitor an elderly person who wants to live at home in their house by themselves, independent for as long as possible. That same technology today can actually use a radio field to determine if you're having a stroke, because it can look for characteristic movement where you get asymmetrical movement. If the brain has a blockage, typically things are uneven. Can immediately not only call emergency services, but it can call specialists in the emergency services that know how to deal with a stroke victim. So we have an entire division that is focused on IoT health already today. In fact, if you get a chance, if you search on the words Eric Dishman, Intel, I highly encourage you to do it. It's a man who came to Intel by using one of our servers and some of our devices to diagnose his own cancer and design a custom set of drugs to cure his cancer from something that was stage 4 uncurable cancer. And he now leads this division using the power of what we're making here. And then finally, the infrastructure that connects it all. Security, privacy, protection of information being at the very top of the list. And thinking about things like security in a whole new way. If you look at security today in most of the industry, it's medieval. It's about creating a castle with big walls and a moat around your city to attempt to protect it. But in a world where everything's interconnected and things are going in and out of the gates and underneath and down from the top, that system no longer works. How do you build security systems that are embedded into every single piece of information or application instruction between all of these devices and the data that they create? API management and data management. Analytics is just massive. The vast majority of data today that's collected is simply thrown away and not used. Even those GE jet engines today, I'm trying to remember, it was greater than 90% of all the data is simply thrown away because there is no way to digest it and analyze it fast enough to do all the work that you want to do with it. So real-time analytics, deferred analytics, decision-making support, and then the visualization of analytics is huge. Because unless you visualize analytics so that humans can do something about it, the analytics are pretty useless. Big data management, the communications infrastructure, as you can see, is going to be vastly overwhelmed if we generate the types of data that we're talking about. You know, I got the chance to go down into beneath the pilot seat on a 777 that was managed by the GE systems. It was amazing. I went from a pilot seat into a data center where there was a rack of computers that looked like you were at Amazon with blades stacked up and a complete network infrastructure like you were sitting inside of an Amazon server farm on a Boeing 777 jet. Pretty amazing. And then finally, things like virtualization. You'll see us do some work here where it used to be that you virtualize server farms. Now what you're doing is you're looking at how to virtualize all of these connected devices and servers into sort of one combined blur or cloud of computing. The difference between servers and devices will really start to disappear. It makes for self-healing devices. If that jet loses connection with the ground, it simply goes on. If the engine loses connection with the central computing, it can go on. It may drop down to lower functionality, but it knows how to intelligently shift the computing power, the movement and the processing of data amongst all the different devices that are done, even with connectivity or connectivity failure. So just some examples of work that we're already doing with the technology we have today and how significant they can be in the real world. So we already today power smart vending machines for Coca-Cola Enterprises Europe. Those systems today utilize, in this particular case I use an example of T-Mobile, to communicate with Coca-Cola's distribution system. Coca-Cola's distribution system now can save massive quantities of fuel and make increased revenue because these vending machines are stocked just in time. If suddenly there's a big sporting game and the vending machines drop down to zero, you can assure that that truck is instantly dispatched to keep the product on the shelves. Because every time that slot is empty, somebody's not making money. At the same time, you can assure that that truck is also not wasting petrol going to locations that it doesn't need to go to. And then you can also even do analytics to then find out where should I put new machines. The thing that's fascinating now is that then that links out to the trucking company that runs those trucks. That trucking company is now linking into their parts supplier. The trucking company links back into the corporate offices, which then link out to SAP, which then link back to the bottling plant that creates the glass bottles, or the aluminum plant that creates the aluminum cans in order to supply this entire network. The thing that's fascinating about it is it automatically becomes viral. It's the Facebook of the industrial internet. Because the second any one of these people gets tied into the chain, they instantly become a new node of the chain. So it's the whole concept of the vending machine invited friends who invited friends who invited friends. So when you build out Internet of Things solution, you always want to have in mind, how do I build it in a viral effect to be reused, new applications to be added on, easily snap-in, pluggable, extendable, upgradable applications that tie to one another. Another great example, this is part of our work with General Electric. So today, in their next generation systems that they're in process of deploying for doing nuclear magnetic resonance, in this particular diagnosis room, there are over 250 devices. These devices in today's generation already have 25,000 sensors in one room collecting data. And these devices are generating data when they're doing the analytics on a patient at 2 terabytes per second. And so you can instantly start to visualize, how can I create the communication systems that can handle that and optimize it, the big data systems that can handle the flow of that data and store it and compress it and make it easily utilizable in a cost-effective manner. So we're working with them on a lot of the solutions to these problems. But the software, people like Intel just make horizontal platforms for people to build real applications on. What we're looking for is people like yourselves to come in and build applications, for example, for healthcare that we could have never imagined. We want to provide the tools and the capabilities to do that, as does GE. to take their things and use them as a platform. Another one, the city of Munich, is part of something we call smart cities. They are utilizing street lamps as tools, as sensors. They're using a combination of cameras and lasers and photodiodes made with LED lighting to be able to automatically detect movement of objects below and identify things like how full is a parking lot. And they're going to even start to do things like guide a car directly to an open spot. But they will make sure that the spot they're guiding it to can accommodate the vehicle. Or perhaps the owner of that particular vehicle might want a premium spot, who may be willing to pay for it. So they're utilizing it for everything from violation to revenue increases to even going through and optimizing shopping experiences. Because, let's be real, cities are built on the backs of their companies and their enterprise. So increasing the amount of people that can be served in any minute of the day increases the tax base and benefits the residents of that city. In fact, we actually already run today, if anybody of you use the phone-based charging system for Starbucks, that's all of Intel's API systems. Today, roughly 25% of all the revenue of Starbucks comes from using your mobile phone to pay for your coffee. So just a massive quantity of revenue generated from that. What are the key elements of the API platform? So if you look at across some of the vertical solutions up there, location, big opportunity for everyone in the room. Data as a service, being able to optimize, store, analyze data. Network as a service, with such vast quantities of data moving across the network, treating the network not as pieces of copper wiring or of light, but instead as a software programmable interneural network. There's ways of optimizing the flow of information that are optimized, again, beyond what we could even think of today. Security, trust, API access and management, analytics on APIs to manage the flow, look at the flow of information. Steve Jobs rears his head. Commerce, others. The key elements we see is configuration and management of the devices to keep actual functional, capturing and controlling of the data, connecting and protecting the data, being able to innovate on the data and monetize the data, and then the tools and the deployment of the information and the applications that you have, all built on top of the IoT device network, which not only includes the devices themselves, but the gateways that support them, the network that supports them in the cloud. And then the other thing that's interesting is IoT is really becoming a world of multiple operating systems. Today there's over 15 different operating systems in the world of IoT that have appreciable share. So you need to be fundamentally designing your systems for a world where you can't be comfortable that the operating system is going to be Android, Mac, iOS, or Windows. There's a massive number of operating systems out there that you need to design for. So I guess in closing, what I'd encourage all of you to do is to really capture and seize the day on this new change in computing. We are at the dawn of a significant shift in the way intelligence and computing will be applied that the world has never seen. And as you look, each time this has occurred, from mainframes to PCs, then out to mobile, right? There's more people in the world today that have mobile devices that have access to clean drinking water. People would rather talk on the phone than drink. So, UN statistic was kind of scary. The impact that it has on society multiplies by orders of magnitude. So the opportunity that's here for all of you to capture that opportunity to improve society, to improve our planet, to improve the quality of life is just massive, and the time is now.
Okay, so we'd like to invite up Ben Green and Bill McCluggage as well. Hank, thank you very, very much. I think this panel is going to be fun. So if I could just start with Bill, if you wouldn't mind, I think our... Bill, if you wouldn't mind just introducing yourself quickly and very quick.
Hi, I'm Bill McCluggage. I'm the local chair of the Belfast branch of the BCS. I'm here representing the BCS. My background over the last few years has been in the Air Force here at the shipyard. I was in the public sector here in Northern Ireland, Deputy Government CIO in the Cabinet Office, CIO in Dublin, and I'm now out doing my own private consultancy.
And Ben?
Hello everyone, my name is Ben Green. I'm on the local committee here for the IoT. Up until this day last week, I was director of SAP here on the Science Park. I've since left that and now CTO of Analytics Engines. So playing to the Intel card that Hank's been showing, we're focusing specifically on big data and how do you actually do the processing and at the scale that the data is coming towards us. So when I see the 35 zettabytes, I'm looking excellent. That's exactly our game where we want to be.
Okay, so I've got about 20 minutes worth of questions. So I asked about 5 or 6 people just for their ideas of what are the areas they'd really like to explore with the panel whenever we did the moderated bit, and then I'm just going to come to the floor for any questions, about another 20 minutes for any questions that you might have. Now I'm going to start with Hank, because that was an excellent presentation. Thank you very much.
Thank you.
But sensors are nothing new. But if the time is right now for a phenomenal shift in this entire space, what are the key factors behind this timing being right now?
I think what you're looking at is advancements in connectivity, right? The ubiquity of wireless connectivity, and by wireless I mean, now for example, this new sensor board that we're releasing right now called Galileo has everything from Wi-Fi to mobile to Zigbee to Z-Wave to NFC is all built into it, and it's inexpensive to build now. So the cost on this has dropped to the point where deploying this in fairly inexpensive devices is there. And you get to use the communication capabilities that are most appropriate. So cost. Okay. The next one is advancements in sensing technology, which also is coupled with the reduction of cost in sensing technology. So you already see The latest watches now starting to come out with things like heart rate monitors and in some cases blood oxygen. Well, some recent advances, you're going to see this accelerate dramatically. There's new technologies now that use radio frequency that can measure the exact levels of sugar in your bloodstream, that could dynamically adjust insulin doses to match the overall profile of the day for a diabetic patient. Today it's a complete guessing game. And those sensors, the cost of those sensors has dropped dramatically. Then you couple that with computing power. Our new Quark chip was it maybe here? Okay. Has the computing power that is beyond that of a Pentium computer, and a chip that's the size of a quarter of my pinky nail.
That's your little finger, by the way.
That chip, and actually its next generation, can run on the power requirements of the solar panel that's used for a calculator that you would use in your office. And the price point of that chip has dropped dramatically. So you got computing, you have I/O, right? You have a way of communicating back and forth with the object. Think back to mouse, computer screen. This is the new I/O. And you have the ability to do intelligence, all combined into a package now where the price point is something that is getting close to the point where it may even be a throwaway for certain applications.
Yeah, well, I think there's another part there that there's the whole culture part. We've lifted up and grabbed social media, and now we're about to take the step where we're at this point we're used to sharing our information out there. Now with the whole Internet of Things, we're going to get the next bit where we're not doing the active sharing. The device is doing the sharing for me. And I'd say my wife loves this idea because when I go running, she's terrified about I might not come back. I don't run that far. And she loves this idea of being able to track. So I sort of look at it going, it's scary, she's following me. And she's looking at it completely different way. She says, it's scary that I can't follow you. And I think there's a big shift that way, coupled with that people just want to be able to get this information. They also want to be able to say, well, I ran this far, how far did that other person go? So there's a great part of that comes into place as well.
Okay, so it's becoming, society's getting used to oversharing. Bill, anything else?
I think we heard a very eloquent talk about the technology, and we're all here fairly technology focused. But there's a massive piece on the other side of this, which is about the adoption and the acceptance of society, the legislation and the policy making that has to go beside this. From an international perspective, we are different cultures. We have different rule sets. It took us a while to get IATA running, so we had an international air transport capability to travel around the world safely and have a series of standards and policies in place. But I think if there's one thing I would say we need to learn from the past is how do we address the marginal areas of policy making, laws, ethics, academia in terms of driving this. But I think there's a large amount that surrounds the Internet of Things that we could usefully start to look at in terms of how do we take thought leadership to the next level on the Internet of Things.
Okay, so staying on that, Bill, and with you, so the nightmare scenario and all of this is, everybody's seen Terminator movies, right? Skynet, and then the self-thinking machines. Humans are the enemies now, and they need to be wiped out. So, what are the key things that are going to need to be got right? Okay, that's pretty extreme, but even in today's priorities, whether it's privacy and all of these things, from not just the standards and the connectivity, but on the privacy side, what are the key challenges for governments now in looking at this kind of challenge?
I think when you look at I'm ex-Air Force, so I remember some 15, 20 years ago, some of the more advanced fighter jets. And we had to build in physical pilot control over the automated controls the engineers had actually put into place that took away the need for a pilot to actually interact with its hydraulics, electrical systems, because the pilots wanted to feel in control of the aircraft. So I think we've got to be able to turn around and say, what is it that puts us into a situation where the machine-to-machine interactions, which have become so complex in an IoT environment that we can't even understand them ourselves, are actually kept within the bounds of cultural, political, and societal control, so that people can understand what it is that's happening in that fantastic new diagnosis room, but it's downloading 20 terabytes of data on me a second. Right? Where's that going? Where is it being? How is it being controlled? What is the outcome likely to be? Or is it all going to be fed to a high-priced Watson computer, actually owned by the medical insurance industry? Those are the sorts of questions I think, well, we have to be able to be comfortable. We won't be comfortable because this is a mind-shaking epoch change. The internet, now the Internet of Things, we need to, I think, start. And Belfast could be a thought leader in this, in terms of we've got Queen's University, we've got legal, we've got technical capability. We should be starting. I come from the BCS, where there's quite a strong policy branch in London wanting to stimulate these sorts of types of discussions.
Ben, what else do you see as the real challenges, societal challenges, in the whole opportunity or the challenge?
Well, I think there's a part here that how I would go about doing it is one way. I'm looking down here seeing this generate innovate, and I know they're going to look at this whole thing in a completely different way. What I would come up with as a solution is completely alien, and it's not going to be something that these guys are going to take and run with. I think to make this thing's going to happen, government is going to have its policies on things, but the way software is being developed at the moment, you hack some things together. Intel are bringing tools, prototype kit forward. People are just going to build stuff, and whatever works well and is cool is just going to take off, and government's going to have to sort itself out and work out, oh, well, actually that's we're going to have to incorporate that into the policy and sort of be quite flexible and adaptive to how this is going to change things.
Hank, what have you seen, and whether it's different attitudes from different governments, or what are the priorities whenever it comes to, I guess, that feeling of responsibility? You have to police this in some way?
Well, the problem with most governments today is they're probably about 10 years behind the reality of what's going on. And they're probably 25 years beyond the human attitude, right? You know, you have a lot of government policymakers today that sit there and talk about, oh, how do I lock down all of my personal information? And they fail to recognize that, you know, how many users are on Facebook today? We're about 1.5 billion, I think. So 1.5 billion of us have already given up the complete intimate history of our life from the time we turned 8 years old. And those people are perfectly comfortable with it. It's amazing. And so I think one of the things that government and policymakers need to do is, particularly on the consumer side, start to really look at, not from the point of view of fear and protection, building the medieval castle. They need to look at what users really want to be done with privacy information. And then there's going to be also, from the industrial side, of course, what is the aspects, the medicine and so forth. The big one we see there, and we've done surveys of people, the key thing people want to know is who have my information and what are they using it for. And that's what they're all about. People don't mind that they have their information, particularly if they get benefit. But they want to know who has it, what's it being used for. In fact, some of the things that we played with in our testing is, are there capabilities to have privacy mapping where you could actually, right here is something that everybody should be able to see. What's my privacy map? How far has my information gone, and to whom, and what do they have? That should be a basic human right, in my opinion.
Has anybody looked at monetizing that? Because what I'd love to do is say, well, I'll wear this, but I want $5 a month for wearing it. Have people been looking at that yet?
I haven't seen anybody yet who's done that.
Okay.
I think there's I think there's an opportunity